for specifically the constant pressure and also he said that why and always greater than CV for gases, most of the liquids will be just almost about the same. So the heat at what is specifically at constant pressure, the amount of heat that is required to raise the temperature by 1 degree Celsius or change the by 1 degree or 1 degree. Why is it not always this heat? If you plot the enthalpy or the constant heat, H are linear, this will be U versus T, this will be H versus T. Why the enthalpy is at a much faster rate? Why the specific at constant pressure is more than specific at constant volume? Let us see that one. If you fix a volume, there is this piston cylinder, I put a pin here, and this is not getting it. So the pressure keeps on making it, but it's not moving. So whatever heat I am giving to the system there, will go to raise the temperature of the air. Whatever is happening, we are talking about gases, not liquid state. So this temperature goes much faster. On the other hand, if you put a piston in a bag, if you remove the pins, so as you start heating, the pressure increases, so this can push it up a little bit. Okay. This is what exactly happens in the car. When you put more heat, the piston moves, that moves the crankshaft, and the wheels and so on. So a part of the heat that is actually given here is actually used for raising the piston, that is actually for doing work. So what it means that in order to raise the same temperature to 1 degree, you have to put more heat into it. That's exactly the reason physically how we interpret why the specific heat at constant pressure is greater than specific heat at constant volume. And also from the equation that we have derived that one, just see later. Yeah. Also we saw from this equation that specific heat at constant pressure is actually equal to specific heat at constant volume and plus the gas constant. Of course, I left it at R saying that I did not put U or anything like that. Simply because all of them must be in consistent units. If you are using molar units, this will be universal gas constant. If you are using mass units, this will be characteristic gas constant. That's I left it just floating, so that whatever is convenient for you, you can just use that. Okay, the units will be always choose for kilogram cubic. Now, for a constant temperature isothermal process, dP plus dW is equal to 0 because there is no change in temperature. Specifically, the internal energy is simply product of specific heat at constant volume times the temperature differential. For an isothermal process, there is no isothermal, there is no temperature change. So, internal energy change will be equal to 0. So, this is because dP is equal to 0. Now, let's move on further. We can now explain to you why physically specific heat at constant pressure is greater than specific heat at constant volume. Okay. Now, let's go to the next slide. Now, the ratio of the specific heat at constant volume, specific constant pressure, specific heat at constant volume is designated as gamma or the is actually reflex at pure level of thermodynamics. Let us call it isentropic index or whatever. Otherwise, we will say this ratio of specific heats. It's not really the isentropic index that we will see when we do come to real gases and so on. That's also designated as gamma. Let me also tell you that in some textbooks the convention is to designate it as K. So both notations are valid. We belong to old school of thought, that's why we put it as gamma. If you see some of the new textbooks that are there, they will be denoted as K because the specific ratio of specific heats. And that's because the ratio of specific heats for ideal gases it is also the isentropic index. For other substances also it is isentropic index. So in order to be consistent with the various types of gases, they use the specific K, English letter K, they are very common. Now, Cp and Cv actually the increasing temperature that we can see. The previous figure I showed where actually the straight line we assume that is for perfect gases, where the specific heat on Cp and Cv they become constant. Remember again, recap, perfect gas, specific heat are just constant at all temperatures. For ideal gases, specific heats are only functions of temperature. For real gases, specific heats are functions of pressure and pressure. That's how you will distribute it. Now we are talking about ideal gas. If you take the ideal gas, specific heat at constant pressure and constant volume are functions of temperature. So if you plot the x1 excess U, what will happen is one specific heat something here. So we will see V times delta T will also be very close. So it will keep on going up. Of course, why it is not like this, it keeps on going. It is complex when you look at it from this side. This is U versus T. This is for the ideal gas. In the previous slide, this is for perfect gas. Remember? For perfect gas, U versus H, both of them will be linear. For an ideal gas, that's another way you distinguish between ideal gas and perfect gas. Okay, is it clear? How do you distinguish the ideal gas and perfect gas? It is specific heats which actually determine what is ideal, what is actually perfect. Okay, let's move on from there. Now, as I told you, air is actually a mixture of gases. And this is what we call the standard composition of air and various kinds. So, but still, in thermodynamics, we treat air as a pure substance. So we got to calculate what is called the characteristic gas constant. And I don't know if you have done high school chemistry. Then there is a mixture. How do you calculate molecular weight of a mixture of gases? It is given by the mole fraction, which is actually volume fraction, multiplied by its molecular weight. So if you take this particular thing, the molecular weight of air will be 0.7808, of course, I chopped multiplied by 28, molecular weight of nitrogen. Then 0.2094 times 32, which is actually molecular weight of oxygen. And keep on adding that. All the other things are also done. They don't make much of a contribution. So finally, we see that the molecular weight of air will be 28.97. I'm quite happy if you round it up to 29. 28.97 is pretty close to 29. So you, for all practical purposes in our thermodynamics calculation, we take molecular weight of air as 29, which is also reasonable because nitrogen is 28, oxygen is 32. Most of the air contains nitrogen, which actually has to be closer to nitrogen, but we have got 29. So remember, molecular weight of air 29. This is something that we have got to do. This will be chasing us for the rest of our life or your life. So that's all molecular weight of air. On the other hand, if you want to find out what is the characteristic gas constants of each of these species of air, for example, this is what you get. Are you able to see? Apart from that, or should I turn it a little bit? Or you can turn this apart from this. Okay. So if it is this is characteristic gas constant for nitrogen, the 8314 divided by 28. 8314 in joules per kilomole, because we use the word kilomole because the molecular weight is in kg per kilomole. So 8314 is not 8.314. 8.314 is only in joules per mole. Normally we use kilomole in our chemical calculations, so we stick to that one. So 8314 divided by 28, these are the numbers we get. Obviously, you can just calculate and see if the numbers are given are correct or not. Can you make a quick calculation, please? And check whether those numbers are correct.
Calculator
Calculator is out. You come to thermodynamics, first thing I want you to do is whether you take n out or not is immediate. At least I have to have the calculator. And the pen and the pencil, pen or pencil, and the notebook, of course. So make sure that your pen has got a good remember, I specifically put the word stream. Stream is a vapor, it's a gas. Water is a liquid. So we've got to distinguish ice, water, and steam. We'll discuss about that one bit later, whether it's the cases of any fluid. Is it okay? All the four? All the five rather? Nothing wrong with it? No, don't copy from there. We calculate and put it down there. So there are what are called characteristic gas constants. That is, units will be joules per kilogram per kilogram per Kelvin. Okay, all of you happy with it? Are the numbers? Did you get it? Did you get those numbers? All of them. Chesava? Chesava. Okay, this is actually. Now we'll go to a process. Now I will say, I told you that normally, suppose, let me take it away from thermodynamics. Suppose you are going into town, I'm not going to use town planning. You see the older way the town was planned, on Patur, Kodur, Lendical division. Is anyone from Patur? Anyone from Patur? Or Old Town? Anyone from, only one person from Patur, Old Town, is it? Oh my God. Only very few intelligent people in Old Town. Okay, Kodur, New Town, only one. Where do all the other people come from? 1, 2. Where do all the other people come from? Yeah. All the other areas are. So if you see the showdown layout in the olden days, what you had the first road, you had the second road, you had the third road, then you had the crossroads. Okay, so you have the roads going from north to south, you have the roads going from east to west. And if you go to some of the cities, if you go to town planning, you've got precincts, you've got the cul-de-sacs, and you've got so many. So a town planner, what it does is that it lays out the roads in a particular way, so that people can go. For example, if everyone tried to build a road right from the college, college road built just say, you see what is the fate of the town. The total chaos and confusion. So best thing is a municipal engineer, town planning engineer, what he will do is if you give north to south, east to west, presents, cul-de-sac, handicapped. So these are the various paths which allow you to go from point A to point B. How do you do the direction? You go right along this one, along the road, JNTUA road. When you get an intersection, take the left turn. From there, go further down. After you pass the collector office or OTRI, take a first left turn that's available. Then when you go to another junction, take a left turn and keep going along the road. You pass around the road straight, you go to third town. That's how if someone doesn't know, you give the instruction. That's because you know the roads are laid out in a particular way. Similarly, thermodynamics, when you construct the cycle, you got to tell what is the way in which you are traveling. So for that we have got processes like roads in our real sense. So we got so many roads. One of them I can give you an example of what are various roads. One is what we can do about the D. You move constantly. So now I introduce you a term called U. So I can take this also constant because this will be same as this. If I make U constant for ideal gases, T also be constant. So I can make it P constant. What do they call it? Constant P process? Isobaric. What do you call the constant T process? Isochoric. What do you call the T process? Isothermal. Now all these processes are there. Now we have what is thermodynamics? In the first of thermodynamics says that it is Q plus W. So what we can do is either we can make this one 0 or this one 0 or this one 0. If you make one of them 0, it is easy to calculate the other stuff, right? So if I can construct a process where one of them is 0 at any particular time, easy for me to construct a process. So we already said that delta U is equal to 0 is nothing but isothermal process. Then the W is equal to 0, that means your W is defined as negative of integral of 1 to 2 PdV. See the 0 component is the PV has got to be 0. PV has got to be 0. P can be 0. Okay? A P can be 0 is impossible because it is absolute vacuum that doesn't exist in nature or in reality. So if PV is equal to 0, then change in volume is equal to 0. What do we call the process? Isochoric process. So this is isochoric process. See, one thing I'm glad is there is a lot of chorus coming in. Isochoric is not difficult. That's very good. Keep it up, guys. Isochoric process. That is P is equal to constant. For this, W is equal to 0. This is delta U is equal to 0. And is equal to 0. Then we call it isothermal. Now, this is constant P is equal to 0, we can call it as isobaric. But isobaric process, none of them are 0. You will see now, by none of them are 0. Either delta U is equal to only move then isobaric process. Let us consider one why does it 0? Let's see. D 0 is something. Then 0 is the as thermal. D 0 is the constant very good. Is possibility. Ask yourself, can I make Q is equal to 0?
That is a process in which there is no heat addition or heat removal. Okay? Yes, that process is called adiabatic. That is not very adiabatic is, in fact, in medical terms, adiabatic is someone who doesn't have diabetes. It's not like that. This adiabatic is different from adiabatic. Okay? Actually, also in thermodynamics, we use what is called a diabetic. That means there is a heat transfer there. But in medical terms, diabetic means they straight away they go to give you metformin tablets. Okay. Anyway, you are all youngsters. You don't know what to do. Don't worry about it. Maybe when you grow older, I hope you don't get to that state. But unfortunately, our Indian genes are such that everyone who is about 15 will very. Is there anyone whose parents either of them doesn't have diabetes? Who doesn't have diabetes? No? Everyone's parent has got something or other. Diabetes. Not yet? Okay. Invariably, most of the Indians and Chinese and most of the Asians get that. But don't worry about diabetes. The diabetes completely medical diabetes. We are talking about adiabatic process, which means Q is equal to 0. Okay, now let's go to that. But from the first of thermodynamics, if Q is equal to 0, then W should be equal to delta U. Small p is W or du if it is in the differential form. So by our definition, we have seen that minus PdV should be equal to CVdT because the definition of work is minus PdV, of course in the differential form, and change the specific heat is nothing but Cv times dt. That's what you have written this. So then again, for the perfect acceleration, we have said earlier that Cp plus Cv is equal to R. Cp is equal to Cv plus R, so Cp minus Cv should be equal to gas constant R. Again, I didn't put the subscript because either you can use molar or mass unit. That's the reason I put it. So now how do we calculate gamma out of that one? Let's say Cp by Cv. You calculate here. AGR equal to Cp, no Cp by Cv, and this value, and you know the Cv is equal to gamma is equal to Cv by Cv. So you can redefine this one. Just simply, if you put gamma, Cv times gamma will be equal to Cp. So Cv you can rewrite it as R by gamma minus mu will be equal to Cv. So for an ideal gas, okay, any ideal gas for that matter, and if you know the value of gamma, R is constant 8314. For example, if there is a gas for which gamma is equal to 1.4, for example, air and gamma. So you can calculate what the value of Cv will be in how many joules per kilomole Kelvin. R is equal to 8314. For gamma, of course, it also depends upon the gas. If the polyatomic, monatomic, diametric, I will come to that in a moment in the next couple of slides. So let's say if you got given the value of gamma 1.4, what is the value of Cp and Cv for that one? Okay, how much?
20785.
Sorry?
Cv equal to 20785.
20785. That is, how did you get it? That looks to be 8314 divided by 1.4 is not equal.
Minus 1.
1.4 minus 1.
Yes, sir.
Minus 1. So divided by 0.4. 8314 by 0.4. Okay. How much did you get? 24?
20785.
Okay, then you calculate what is the value of Cp and multiply by gamma in this. Whatever number you got, other is 1.4 divided by 0.4 multiplied by 8314. So many joules per mole Kelvin.
29 $0.
Okay, this is now therefore what we can do is CVdT is nothing but R, this Cv is nothing but R plus R divided by gamma minus 1. This will be R divided by gamma minus 1. That is Cv, P minus P. Okay, now what we are going to do is from here up to this is thermodynamics. From this is from here is mathematics. That is high school mathematics. So shall we proceed further from there? No thermodynamics of this. Make sure the valve is because gas perfect calculation again it keeps on chasing us. Okay, so it keeps on chasing P is equal to RP. So it's during the adiabatic process, P, P and T, all of them can change simultaneously. Okay? So what we do is let us call that the incremental the incremental change you make. I am taking the pressure from P plus dV. Volume from V plus dV, temperature from T plus dV. All of them can change simultaneously. The only thing where it doesn't change is isobaric process, volume doesn't change, isobaric process, the heat doesn't change, isothermal process, heat doesn't change. But in an adiabatic process, there is a general process, all the three of them will change. So I can write this for P plus dP plus P plus times V plus V should be R times V plus V. Okay? So that comes from this circle. P is changing from V to P plus dP. V is changing from V plus dV. T is changing from T plus dT. R is not changing. So I recognize a constant. Okay, then expand JNTUA. You expand this one and write it down. Okay, you remember in the calculus you would have done? How do you find dy by dx when y is given? At y is equal y plus dy, x plus dx and then you ignore the products of small quantities like dy dx. That's what you have done. But then calculus, you know how the differentiation is done. For example, sin x differentiate just at this one. Cos x ఎలా వచ్చింది? X squared differentiate చేస్తే ఏమొస్తుంది? X squared differentiate చేస్తే ఏమొస్తుంది? 2x ఎలా వచ్చింది? So this is what it is. So this will be P times dV, then P times dV, then P times dV. తర్వాత ముందు ఇది రెండు మల్టిప్లై చేస్తాం, తర్వాత ఇది రెండు మల్టిప్లై చేసాం, తర్వాత ఇది మల్టిప్లై చేస్తాం, ఇది మల్టిప్లై చేస్తాం. So this will be RT plus RT cube. Let us not approximate. The dP, dV, they are extremely, if you take increases in small quantities, product of dP by dP and dV will be negligible, so we will ignore it. Compared to this value, it is quite small compared to all the other values. Okay? Okay, can you write down the next equation? What it will be like? So, if you want to understand, dP is equal to RT. Just look at carefully, use your imagination. ఇక్కడ dP ఉంది, ఇక్కడ RT ఉంది. కదా? So, ఈ రెండు కొట్టు పోతాయి, ఈ రెండు పోతాయి. So VdP plus VdV will be equal to RdT. That's what you get. Correct, na?
Yes.
VdP plus VdV will be equal to RdT. I didn't have to go that far because I was written that from the T of P is equal to R. Because I didn't put that. I wanted to get the R thing. Now, VdP plus VdV is equal to RdT. Reduces to that. That's it. So now, what we substitute is for R is equal to RdT will be equal to negative of PdV by gamma minus 1. Remember from the equation A. Let's say what is equation A. Equation A, but negative of PdV is equal to RdT by gamma minus 1. This is the second method. Okay, can you do that? This is what you got. RdT marker replace here. Replace is same with the other dV right. This correct here. This mark minus PdV that's gamma minus 1 should be equal to correct, na? This is algebra. It's only thermodynamics here. Okay. If you know algebra, you understood what I am doing now. It's not an idea. Then you again rearrange the terms. So PdV comes out of this one. PdV equal to PdV. The minus PdV by the against it 1 plus gamma minus 1. So this will be actually gamma. 1 plus gamma minus 1 is nothing but gamma. That should be equal to VdV. Again, remember guys, is all algebra. There is no thermodynamics here. Correct or not? Okay, let's go to the next step. Now, this is nothing but 1, this is nothing but gamma, and you 1 and this one get cancelled. So, minus gamma of VdV is equal to V. ఇప్పుడు దీన్ని ఇంటిగ్రేట్ చేద్దాం. మనం ఏం చేద్దామంటే dP ఉన్నదంటే dP by dV, ఇక్కడ dP ఇక్కడ ఇంటిగ్రేట్ తీసుకుంటే ఇక్కడ dV కింద ఇది వస్తుంది. సో నెగటివ్ ఆఫ్ గామా టైమ్స్ dV by dV equal to dV by ఇంటిగ్రేట్ చేయండి ఏమొస్తుంది? What is integral of negative of dV by dV? Integral of dx by x anta. Come on guys. Huh? Log. E power. What is it? Don't read it from there. You must know that integral of dx by x is equal to ln of x. That's what I have done. So derivative of gamma times ln of p should be equal to ln of a negative 4 times because integral of dv by this log of p, ln of p is ln of p. Ln is remember the natural log. When it is an actual log, we put as log vulgar. Log means this will be a stand, and we will say n means natural log, which is e. Okay, now what we will do is because then the constant has to come because whenever you are doing an integration, there has to be a constant there, unless you are doing it in limits. So that is a constant that you have put here, constant negative of gamma ln of p should be equal to ln of p. So that is even this here. Ln of p plus gamma ln of p should be equal to. So this is nothing but gamma ln of p is nothing but ln of e power gamma. Because what is ln of x squared? 2 ln of x. Same thing. Gamma ln of e. So this is ln of then then ln of a plus ln of b is equal to what? Logarithm of AB. Oh my God, all of you remember that. That's good. Good. Much more than we can do. So this ln of PB. So now ln of PB power gamma. So PB power gamma is equal to this another constant, which is actually this constant we didn't fill in number. That's some kind of constant. We don't clear it. That constant can be another constant. So what we got finally is PB power gamma is equal to constant. That's what we got. Friends, that is actually the equation for an adiabatic process where Q is equal to 0. Now later on we will qualify that one. It is just only adiabatic. Then we talk about reversibility. It has got to be reversible and adiabatic. That only is valid for at lowest level of thermodynamics. It is sufficient for you to remember that PV power gamma is equal to constant is adiabatic equation of a process. This is nothing to do with the equation of state. Like PV is equal to RT is an equation of state. Incidentally, PV is equal when the temperature is constant, PV also describes a path. When P is equal to constant pressure, that's actually it describes a path. When P is equal to constant, it describes a path. PV is equal to constant, describes a path. Similarly, PV for gamma is equal to constant, it also describes a path. What is the path? It takes from state point 1 to state point 2. So, because, like I said, when you construct a road, I want north, south, east, west, crescent, and cul-de-sac, I have to describe what kind of a road I am constructing. So this is one of the roads I am constructing. There is nothing to do with the endpoints. This is a path I am going to follow when I am built from state point 1 to state point 2. Okay, let me take a breather. Any questions at this stage? Because there is better. Like I said, most of it has been algebra. The thermodynamics ended by the time you appreciate that PV is equal to constant and you wrote the equations for CP and CB. Okay? Okay, guys, any questions? This is not clear? Clear? Is clear this way? Horizontal shape or vertical shape? Okay, right. Let me go to the next slide. Okay, now once I know what the path is, I should be able to calculate what the integral is. What is nothing but if I can calculate this integral provided I know how to measure this in the first column. Now I have the equation. So I should be able to calculate what is. The whole idea is what either you should be able to calculate Q in order to do the two things we require in the model. In order to calculate U, I need the T2 minus T1. In order to calculate W, I need to evaluate this integral. In order to calculate Q, at the moment, you don't have a procedure for doing it. But if you have those two, you'll be able to calculate Q. Okay, that's what we do. Now, what we will do is we will calculate the integral of work that will be an adiabatic process. Remember again, once again, if we try the point, PV power gamma is equal to constant is not an equation of state, but is the equation of the path followed by a gas when it's going, when it's being changed from state 1 to state 2. At the same time, we are not adding any heat or we are removing any heat. That is Q is equal to 0. When Q is equal to 0, positive this one or the other.
So now we will integrate. Again, definition of it is going from 1 to 10. Then again, you will take about 1 to 2 PdV. That's the basic definition. There's nothing. That's again thermodynamics. The negative sign comes in because of the fact that we are following the sign convention, which is where what going in is more positive, but going out. Okay, now we can write this one as when it is going from when P power gamma is equal to constant, what will be the P will be equal to P power gamma is equal to constant. So P is equal to some constant divided by P power gamma. Is it correct? That's what happened here. When it's going from 1 to 2, because the negative sign comes from there, it's constant, yes, constant. Okay, now this, when you integrate dE by V, okay, what is the integral of 1 over V power n? Calculus. Don't look at this. What is the integral of 1 over V power n? I want you guys to tell me integral of dx by x to the power of n.
మర్చిపోయారంతా క్యాల్కులస్ క్యాల్కులస్ ఎట్లా హై స్కూల్లో చేస్తారు వీళ్ళు హై స్కూల్లో
x power minus n plus 1 by minus n. X power minus n plus 1 by minus n plus 1.
I don't know if the other guys get it. Do you know how much is here? The integral of that dx by x power n. How much is that?
Calculus.
Exactly to the gamma. And you apply the limits. First apply this limit. This is v to the power of minus gamma plus 1 minus v1 to the power of minus gamma plus 1 divided to minus gamma plus 1. Again, guys, up to this it is thermodynamics. From here it is just algebra. Please remember, if you have forgotten your algebra, if you have forgotten your calculus, thermodynamics will be like a magic. Okay? You have to brush up. If you don't know, I'm sure if you haven't done calculus, you wouldn't have got into engineering. It's as simple as that. Every student, they say even the high school itself now, maybe in year 11 or year 12. Okay? Is there anyone who hasn't done the calculus in high school? Otherwise, you wouldn't have got into engineering without doing that. At least you have done it in first year engineering. There will be maths and you would have done it. It's absolutely essential that you brush up your calculus knowledge before you come to the thermodynamics class. Otherwise, it will all be like a magic. Okay, for people who don't know, just take this as an axiom, go back to our rooms, integrate, because in the next class I'm going to ask you to do several integrations. Where actual integration will come, I want you to do those calculations now. So please brush up your calculus data. So this is what it will be, minus gamma plus 1, minus gamma equals minus gamma. That's what it will be, applying the limits there. But Vv is equal to constant. Now, which means that, because again it's a process, at the beginning of the process, V1 power gamma should be equal to V2 power gamma. It's again the process. At the 2 gates, the process it has got to be satisfied. So what we will do is we take this one as a we will rewrite this one as V2 power gamma, because this constant I can write as V2 power gamma. So there is negative sign. Please remember to carry forward the negative sign. If you don't do that, again you will mess up the equations. The negative sign I am carrying forward. This constant I can replace by V2 power gamma, because the V2 is already good. I can also put P1 here, but it's more convenient when I have V2. Okay, into what? One to the gamma, take it away to the point. V2 power gamma times V2 gamma. This one. Similarly, this V1, this constant I will replace with V1 power gamma, negative of this one. ఇక్కడ ప్లస్ గామా ఉంది, ఇక్కడ మైనస్ గామా ఉంది. ఏమవుతుంది? What will happen? V1 power gamma times V1 power minus gamma plus 1. How much will it be?
V1
You add X power 1 is equal to X. Simple here. The gamma and gamma both is B1, this is B2. Guys, you know that thing, you don't tell me that you don't know this. If you can do that, you should be able to do this.
Yes.
B2. So this will be negative of B2, but remember the denominator is minus gamma plus 1. So always gamma will be, who should it be greater than 1? Simply because, why is gamma greater than 1? How did we define gamma?
CP by C.
And what is the nature of CP and CP, which is bigger?
CP.
So CP by C, so it will be gamma will be greater than 1. Simple. Common sense. Use the common sense. This is always gamma. This is negative. So this negative sign will absorb and make this one common. So that's all. So it will be work done in an adiabatic process. Is B2 minus B1 divided by gamma minus 1. That is actually after the equation you have total amount of work done in an adiabatic process. Okay, is it clear? I know, again, let me repeat. Thermodynamics is over here. And all this everything is nothing but touching on your calculus. You don't know? I can't help you. So I can't tell you because Kalyan Kumar, I don't teach thermodynamics. I can't teach mathematics. Because I can teach mathematics, but the time available is too limited for me to teach mathematics. Okay? Okay, now this gives this is not an equation of state, and let me emphasize that it is only a description of a path followed by a specific process. That is what is adiabatic and also reversible. I put the word reversible, but don't worry about what is reversible. And holds and they also it holds only for a perfect or an ideal gas. Not for real gases. Because for real gases you cannot apply that. Is it clear? So now we have got 4 processes. Another process we have got is another one Q is equal to 0. So these are the 4 processes we have got. Okay, with this 4 process we can do check up the mix and match. Like you can have aloo gobi, chana, chana masala. You can do any masala and then you make various curries. So similarly we do the same thing. Isothermal, isobaric, isochloric, adiabatic, and all this. So with all this, this is what all the curries they do. They have their curry is big same. They have got different aloo gobi, chana, gobi. What is that? Gobi paneer, aloo paneer, everything. How all the things you make different combinations, you get different curries. So similarly, you make different combinations, you get different processes. Okay. So we have right now we have got 4 isobaric, isochloric, isothermal, and Q is equal to 0. That means we have got covered everything where Q is equal to 0, W is equal to 0, delta is equal to 0. Everything we have covered. Okay. Now, this occasion we make some calculations based on this one. Here is a question, and I want you guys to do the calculation. I'm going to give the question. Okay, I know some of the intelligent people they will just take a snap of that some with their cell phones and then start it. Don't do that. Okay. Here is a problem. 1 mole of argon, and the molecular weight argon 40. Okay, if you don't know this. Nitrogen 28, oxygen 32. Everything is only when calculates like methane 16, water 18. Okay, so argon is 40. It is 26.85 degrees Celsius. Then the 26.85 becomes there, sir. Every bit is 26.85. Why did you take 26 or 27? Why did you do that? As Kelvin to convert your centers. అందుకే నేను 26.85 పెట్టాను. You can take any temperature. It will be easy for you to calculate. So 26.85. 1 mole of argon at 26.85 degrees Celsius is compressed from 1 bar to 8 bar. Okay, by various processes. 1 isochlorically, 2 isothermally, adiabatically. Of course, I not included isobaric. It's not compression, isobarically. Cooling, I will repeat that later. What I wanted to calculate for each of these processes, I wanted to calculate Q, W, and delta U for each of the processes. And I will also give the data for the specific heats. Data for argon is for non-compounded gases. Generally, it is here U is universal gas because it's the molar units are giving 3 by 2 RU for, is not 3 by 2. It is 3 by 2 RU is equal to 3 by 2. That is 1.5 times RU universal gas constant, specific heater, constant volume. So obviously, specific heater constant pressure will be, how much it will be? CV plus R should be equal to CP.
CP.
RU plus this particular length of the. Come on, guys, calculate. 3 by 2 RU plus RU is equal to how much? You don't need the calculator for that, my friend. RU by T is 3 by 2 plus 1 is
3
equal
by 2,
to
5 by 2.
5 by 2. So 5 by 2 RU is nothing but CP. Okay? Guys, get it? 5 by 2 RU. Appudu gamma ento undi? CP by CV. 5 by 2 divided by 3 by 2. Enta? 2 5 by 3 is how much?
1.6.
That is calculated కావాలి.
1.6.
Calculated కావాలంటే what is the quality of education I don't understand. How much is it? 5 by 3? 1.667 వస్తుంది. They will round it to 1.67. Okay. This is what is called a small round of 1.67. Okay. Have that numbers with you. Okay. Now I'm going to turn this one off. I want you to calculate what is the isochronic work. The isochronic process I did. Isochronic process అంటే ఏముంటుంది? Isochronic. The first one is isochronic. Actually, we don't know what it is, but I have given you the value of P is 1 bar, and here the temperature is located K, and this RU is equal to 8314 joules per kilomole Kelvin. Okay, first one idea is V1 catalytic. Take one and look at V1 and think of V1. How is V1? V1 will be nothing but N, number of moles is 1, nRT by P, correct? PV is equal to nRT is equal to equation of state. Because this is equal state, so P will be equal to P times P is equal to N times RU times P. So how much will be P? P is equal to N is equal to 1, RU is equal to 8.4, temperature is 300, divided by 1, P times 5. Because 1 bar is 10 to the power 5 pascals. Enter. Enter. Good idea. So, you want to please? This is simple. I'll give you a detailed if you give the next few numbers are good. It means about how much? 24.4 was that number? How much is that? 24.94. I found it 24.94. So this will be okay. So isochronic and rate account constant. Second point so what will be the stated point 2? Point 2, what will be the temperature pressure? Of course, we also said that it is going to be compressed air. How much will be temperature? So apply the ideal gas equation of state. So we know that P1 by P1 equal to P2 by P2 right now? Because ideal gas equation of state is very the equation of state is very points. So that's why I have to. So here P1 and P2 are same. So you know P1, you know P2, you know P1. Find out what P2 is. Some kind of professions. And again, first one you will guess correct answer will get 0.02. Temperature. I want you to.
I put it right.
Temperature low.
P2 8 bars. P1 1 bar. 18.
300.
8 into
300 times 8 is
P1
Look again. Temperature is 300 Kelvin.
18314 into 300 by 183. RU into T.
ఎట్లా వచ్చింది 2600 300 times 8 ఎంత P2 by P1 ఎంత P2 is P2 by P1 300 P1 is 300 multiplied by 8 so 300 times 8 ఎంత 2600 okay does everyone get 2400 okay now మనకు T1 తెలుసు T2 తెలుసు
Isocoric P1 need to cancel this.
so can you calculate what
Don't bother about calculation.
what is delta U? Change in internal energy is nothing but CB times T2 minus T1, correct? Change final temperature minus
300
heat
into
temperature.
H.
So it will be
Window bell అవన్నీ ఇక్కడ మళ్ళీ అర్థం కాదు.
delta U will be equal to so here the temperature T2 will be equal to 400 Kelvin. So your delta U will be equal to CD, which is nothing but 3 by 2. R is 8314 multiplied by 2 minus T2 has this will be how many? This will be joules per mole. That's a huge number. You can convert it to kilojoules and you can tell me how many kilojoules. This divided by 1000 will give me kilojoules per mole. Sorry, kilojoules per mole. This is kilomole, this is about this joules per kilomole. Weight kilojoules per kilomole. Okay, how much is that? Change in internal energy for a constant volume process. ఎంత అమ్మా? 26189. Yes, you get a treat. Okay, 26189. ఎంత వచ్చింది? Good. That is kilojoules. It is 1020 kilojoules per kilomole. Okay, that is the constant. So if that is delta U, what done in the constant volume process? What is W?
0.
Very good.
Q and then.
So then what is the Q then? How much Q? Q plus W is equal to delta U. So for the constant volume process, the Q
26189.
26189. Same, it is the same number. Okay, done? All of you are done? You have learned what is meant to be a constant volume process. You know how to do it. Okay? Shall we go to a little bit more complicated one? Let us do the isothermal process next. Isothermal process the temperature will remain constant. So what will happen is it will go into 8 bar. So that is for the isothermal process, you do this one. For the isothermal process, we have P1 is equal to P2. P2 is constant. Right? Good. For P1 is 1. P1 under 24.94 because when you have 24, then P2 is equal to 8. Then you can find out what this is. Find out what P2 is.
Three point 1175.
And here the temperature will be say 300, but this volume is to press closing that I will drop it to 3.08 or 3.2 as per this. Okay? Right, I know what 0 because for the isothermal process, what is delta U is equal to 0. So that means Q plus W should be equal to 0. I will calculate what W. W is equal to negative of integral of 1 to 2 PV. So P is equal to RT by B. The equation is R and T because temperature is constant. It will be negative of R times T integral of 1 to 2 PV by B. So that will be equal to negative of RT. And then of P2 is 70.08 divided by 54.24. T is equal to 300, R is equal to 83.4. And calculate how much is converted to joules and we will tell you how much is that. So I have not been faster because I am expecting that you guys know that is dV by D, you take log of P. So log of B2 is defined not 8, Q is defined by that. I am assuming that you guys know in the integral of dV by D is equal to delta. Okay, again, same. The first one gets the correct answer, will give it please. Who will be this kind of water? B2 is take whatever number you get. Don't worry about it.
518.
Sign? Sign, what is this? Plus or minus? Plus? Anyone says minus? 586, no minus sign. This W is equal to Q plus 516 is equal to 0. And then the W is equal to 586. Q is equal to 0. How much is Q? If Q plus W 586, how much is Q?
Minus 518.
Huh?
Minus 518.
So Q is equal to minus 586. Alright, done. So we have done the isothermal process. Isotonic, we calculated Q, W and delta U. Isothermal, we have calculated Q, W and delta U. Okay, can we do it for iso? That is Q is equal to 0. Adiabatic process. Adiabatic process lo no V2 ఎంత ఉంది ఎట్లా కట్టాలి for adiabatic process can you take just try to meet up. And if you know how to do the rest of things, you will follow it. So P1 for gamma, sorry, P2 for gamma, for adiabatic process. Everyone adiabatic is okay. P1 is 1 times 10 to the power of 5 times 24.94 power gamma. It will be equal to P2 is 8 times 10 to the 5 times that is P2. No, this P2 will not be here because this is a different process. So this P2 will be there. P2 power number 1.67. 1.67. Okay. Okay. Again, first one who gets the correct number, you take it.
$45.94. 14.9.
14. 14.92. Check again.
1 by power 1 by ఇప్పుడు దాని పవర్ ఏంటి 0.59 దాంట్లో రాదమ్మా 7.1
No, everyone who shout the 7 I have to give it 3. I don't mind doing it. As long as it's unanimous. Okay, 7.1, whatever. How to do the calculation of temperature? Again, apply the same V2, you know.
వస్తున్నాయండి.
Okay, how much is it? How much is it? 691. This is you don't get it already. 1.18 liter. No, this is not for the other. You only work with the rice. Don't look at this. This one is more. That's a bit like 5 times 1.18 divided by 8. Come on.
ఇప్పుడు ఏంటంటే ఇందాక వినపడలేదు సార్, ఇందాక ఇదే అడియాబెటిక్ తర్వాత ఏం కనుక్కోమన్నారు?
Adiabatic.
తర్వాత
No, I will stop there. I'm not going to take any class. There's no point in teaching in your all hungry. I just wanted to get through this part. That's right. How much is it?
ఓకే
have to use the process and also you must use the equation of state. At the end point, it's always the equation of state is valid. Etama? 690. So some slight differences will come because we are 1.67 actually. So remember for adiabatic process delta U, Q is equal to 0, delta U equal to automatic W. So you have value of delta U. Q is equal to 0. 4876, 4880, 4883, correct? This is back. Okay, so Q is equal to 0. అన్నీ మనం కట్టేసాము. Isochronic process Q is equal to 0, Q is equal to delta W. Q is equal to delta W. Isochronic process delta U is equal to 0, so Q will be equal to negative of W. అది మనం కట్టేసాం. For adiabatic process, Q is equal to 0, so W is equal to delta U. అది కట్టేసాం. So you are learned it. Only thing we haven't done is where Anantapur 0. Isobaric process, concentrated process. I don't want to do that one if you are hungry. I will do it at some point. Any questions? Please, so, please brush up your please.
This.
అయిపోయిందా మీ డిస్కషన్ లాస్ట్ పేజ్ ఓకే ప్లీజ్ బ్రష్ అప్ యువర్ నాలెడ్జ్ ఆఫ్ క్యాల్కులస్ ఇంటిగ్రేషన్ అండ్ ఆల్సో హౌ టు చేంజ్ పవర్స్ అండ్ ఆల్ దిస్ మైనస్ గామా ప్లస్ గామా ప్లస్ అని ఎంత తెలియదు కష్టం థర్మోడైనమిక్స్ will become very difficult. Brush up your calculus and then you do the for isobaric process actually you should be able to do it. Please try to do it, otherwise I will do that in the next class. Okay. Then I will sum up with all the processes, then I will discuss what is called polytropic process. I will discuss you okay? Is it okay?
Yes.
Numerical is everyone comfortable with it? Can you please complete whatever is required to do? Can you please recheck all the calculations that you have done so far? Some of you haven't done the calculations. Please come to the calculation by yourself. Don't copy them. And actually this is one reason I am not giving my PowerPoint right now. I will give you the entire PowerPoint things will be given to you at the end of this what is this unit. Okay, thanks a lot. And